YouTube channel Programming with DPWala. Today we are discussing the very interesting and the famous interview problem that is already asked in many interviews. The name of this problem is best time to buy and sell stock with cooldown. So in this problem we are given an array prices where prices of I is the price of the stock on that particular day. In this problem we need to find the maximum profit that can be achieved. We need to see some of the constraints that they have given. First, uh, we need to buy any stock and we need to sell that stock. And after selling that stock, there is one condition that they have given that we cannot buy the stock on the immediate next day because that day is the cool down day. So we need to maximize the profit and calculate the maximum profit that can be achieved. So let's discuss this problem with the help of an example. So here we are given an prices array which consists of the price of that particular stock on the particular day. The price of the stocks are 1, 2, 3, 0 and 2. The array is starting from the index 0 and we need to calculate or we can say we need to maximize the profit and print that maximum profit. So here what we can do is that first we will start with the index 0. So what are the choices we have? First we need to buy the stock. Here, selling is not possible and cooldown is not possible as we can say, we haven't buy any stock. So here we need to buy the stock. There are two choices that whether to buy it or not buy it. So here we can clearly see that whenever we have two choices, what we do? We simply apply dynamic programming. As in my earlier videos as well, I've explained that whenever we need to calculate any maximum or minimum thing and we are having two choices whether to take it and not take it, at that time we simply apply dynamic programming. So if you are having any queries, I have explained in my earlier videos as well that when to apply dynamic programming. So here we can simply apply dynamic programming. First what we do, first we build our recursive solution which will calculate all our values, but there is a possibility that there is a condition where overlapping subproblem case is there. So to handle that overlapping subproblem, we apply memoization technique, which is a top-down dynamic programming approach. So in this problem, first we write the recursive solution, and then after that we will optimize it with the help of memoization technique, which now our solution become dynamic programming solution. So let's discuss what is the approach behind this problem. So for this particular test case here, first at the 0th index, we will buy or we can say we will buy the stock. So we need to give one price to buy the stock. So after that, what choices we have? We need to sell the stock. So we need to sell it. But they here there are two choices to us that whether to sell it or not sell it. So at that time here, what we can do? We can sell it. So we can sell it, and now as we have sell it, we can calculate the profit. So here what we can do, 2 minus 1 is our profit. And as in the question mentioned that after selling the stock, uh, uh, after its in the immediate next day, we can't sell or we can't buy the stock because it is a cool down period. So at index 2 we can't do anything. So we simply move to the next index. Here at the index 3, we can buy our stock. The price of that stock is 0. So we buy that stock. Similarly, now the choices we have is that we need to sell the stock. So here after that only one index is left or only one element is left. So we simply need to buy or sell the stock. So we sell at index 4 and the cost of that selling is 2. So as we have sell the stock, we simply count the profit. The profit is 2 minus 0. Selling minus buying 2. So at last we have traversed all the array or we can say our whole array. So the total profits we got is 1 plus 2, that is 3. So this is the only maximum profit that can be achieved from the given array. So we will simply return 3 and we will print our answer. So in this problem what we have done is that we have recursively checked that if buying is possible at that particular day or not. If buying is possible, then we have two choices that whether to buy it or not buy it. If we buy it, then in the next upcoming days, we need to sell that stock. So there is no choices of buying again. So at that time we simply made the recursive call for that. Similarly for the sell position, at that time we have two choices, that at the time of selling we have two choices, that whether to sell it or not sell it. If we sell it, then we need to calculate the profit. If we do not sell it, so then after in the upcoming days we have choices of selling it. So, and one condition we have that I have mentioned here, that in the question they said that after selling the stock we can't buy the stock in at the immediate next day, because this is the cool down period. So at that cool down period we need to skip that day. So we simply increment our index by 2, so that we can successfully skip that day. So in this way we will made our recursive call, and this is the whole recursive approach for this solution question. So but uh, after writing the recursive solution, there are there is a possibility that many such calculations we are doing again and again. So to avoid this, we will apply the memoization technique to further its optimization. So let's see how we can make the recursive call, and how to move forward with the DP solution. So here I have made the recursive calls that we need to do. So there are two choices, as I have earlier mentioned, that if if we can buy at that particular day, then there are two choices, that if we buy it successfully, then we here I have mentioned that minus prices of IDX, means we need to give the cost to the customer as we are buying it. So after buying it, we need to make the we need to make the recursive call for the next index, but at that time our buying is 0, means we can't buy it, because now this is the condition of selling. After successfully buying it, we need to sell it in the upcoming days. Or if we haven't buy it, then we haven't paid anything, so we simply made the recursive call for the upcoming days, and there are the choices of buying it. But similarly, if we have buy the we can say buy the product, at that time we need to sell it in future. So if this statement is false, then we move towards our else part, means we need to sell that stock. So at that time there are two choices, whether to sell it or whether to not sell it. If we sell it, then we got the prices of IDX, means we got that particular price for selling it. So after that selling, we are having two choices. We are having the choices that we can buy the stock in the further upcoming days. But here, as they in the question they have mentioned that in the immediate next day we can't buy the stock. So that as this is the cool down period. So here we have made the IDX plus 2, means we have incremented our index to the 2 position, as we need to skip that particular next day. So for this we have handled this case. And suppose if we haven't sell the stock and on that day, so we need to sell our stock on the upcoming days. So we simply made the recursive call for that. Here 0 is there because we can't buy it, because this is the option of now we need to sell the stock. So after IDX plus 1, or we can say we made the IDX plus 1 call for the upcoming days, so that we need to sell our stock on that particular day. So in this way we have made our recursive calls. So now let's see how to approach this problem, and how to write a dynamic programming code for this particular problem. Let's see. So this is the approach, or we can say the code that I have written for this particular problem. So here what I have done, here I have created the global DP vector, 2D DP vector, where I will store our final answer. For its optimization, I have created a 2D DP vector, and there are two changing parameters. One is the index, and the second one is the whether to check that whether there is a buying position or not, whether to buy it or sell it. There are two changing parameters. So here I have made the recursive call, where 0 is the starting index. We will start with the 0 index of the array. Then at the as in the starting we have only one choice, whether to buy it, and this is the size, n is the size of that prices array, and this is the prices array that I have passed. So here this is our base condition, that whenever our index reaches that ending position, or whether it is out of the out of bound condition, at that time we will simply return 0. Here I have made the recursive calls, as I have mentioned in the explanation part that if the buying is possible, at that time we have two choices, that whether to buy it. So if we have buy it, then we do not buy it again. We will made our buy as zero. But if we do not buy it, at that time in the upcoming days we need to buy it. So buying is possible. Here I have made the recursive call for that, and we will take the maximum of it. Similarly, if the buying is not possible there, and there is a chance of, we can say, there is a, now we need to sell the stock. So at that time, what we need to do, we need to call the same two recursive calls. But here, as we are selling, so plus prices of index we will do, and as we know that after next particular day we will do not we can't buy the stock again, as it is a cooldown period. So we will increment it by 2, as we need to skip that particular day. So after selling it successfully, we have the choice of buying it again. So we set our buy as 1 again. But if we do not sell that stock on that particular day, so then we need to sell that stock on the upcoming days. So buying is not possible. So here I have done the opposite of this in this case. So we'll take the max of it. Here, as we can see that I have passed the three parameters as I have explained. One is index, second one is the buy, third one is the size of the prices array and the prices array. So here, after doing all these things, we need to do the optimization. So here I have made the optimization condition that whenever, suppose as I have filled my DP table with -1, whenever I feel that whenever I calculate that value, I will fill that table. Suppose in future if we get the same value again, we simply return that value, no need to calculate it again. And at the time of every recursive calls, we will simply store it into our DP table, so that in future if we get the same recursive call for that particular day, we'll simply return it here, no need to calculate it again. And at last we return that DP value, or we can say that particular value we got at the final, or we can say the maximum profit we got. So in this way, the whole code is written for this particular problem, and in this way I have successfully applied dynamic programming here. So to approach dynamic programming problem, first you need to be very clear that where to apply the DP and where to not apply DP, and put 4 to 5 things in your mind before uh, doing the dynamic programming question. As many students face problem in approaching dynamic programming problem, they face that where to apply DP. So you need to solve as many problems related to DP, and consider 4 to 5 things in our mind. That first, whenever there is a possibility that we need, or in the question they have mentioned that we need to calculate the maximum or minimum type of thing, and there are two choices are there, that whether to take it or not take it, or we can say the question related to the particular standard question of dynamic programming, such as 0 1 knapsack. All such things are there, and at that time we are simply applied DP. And my one suggestion to all the viewers is that before approaching this problem, let's try the its previous questions. That is, best time to buy and sell stock 1, 2, 3, and 4. It's 4 parts. Because after solving that previous questions, it will be easier for you to understand this problem in a very efficient manner. Hope you like this video, and hope this video is helpful in understanding this problem. If you watch this video till this point, please don't forget to like, share, and subscribe to my YouTube channel, and stay connected for more such Leetcode, code step, code forcer, and daily Leetcode problems analysis. Thank you. Happy coding.